Welcome back, everyone. We're going to be solving LeetCode 1952, 3 divisors. So we're given an integer n. We want to return true if n has exactly 3 positive divisors. Otherwise, we want to return false. And an integer m is a divisor of n if there exists an integer k such that n is equal to k times m. So example 1, n is equal to 2. They give an output of false with an explanation that 2 has only 2 divisors, 1 and 2, while 4 outputs true because 1, 2, and 4 are all divisors of 4. Okay, so we are going to have a variable called count set equal to 0. Now we are just simply going to loop through all of the numbers in the range of 1 to n plus 1 inclusive, or 1 to n inclusive, and if that number is modded by n has a remainder of 0, then we know that it is in fact a divisor. Then we can increase our count by 1, and then at the end of this loop we can return, if the count is equal to 3, we can return true, otherwise we'll return false. So we'll say for I in range 1 to n plus 1, so we can get n inclusive, we will say if I modded by n, if that is equal to 0, we can increment our count by 1, otherwise do nothing, and then at the end we will return count is equal to 3. So let's run this, and we get failing test case 2, why? Let's see here, output false, 4 expects true, 1 to n plus 1, should be n modded by I, is what it should be. So we'll rerun. Okay, we passed both test cases, we'll submit, and it does run, perfect. So what is the time and space complexity of this? The time complexity is going to be O of n, right? We are looping through every single number in the range from 1 to n inclusive, and then we are checking if it is a divisor. So that is going to give us a runtime of O of n. The space complexity is going to be O of 1, right? We're not using any data structures here. We're just simply having a variable to store our count. And that'll do it for LeetCode 1952.